All right, welcome back, everybody. We've done access list, right? That was a previous lecture. We've done access list. We know now about access list and the new way of doing access list, which is insane. All right, but now we're going to talk about securing our network devices. Now, we've pretty much touched upon this when we did in volume 1. We were doing basic housekeeping on the router and the switch, putting in username, passwords, all that. So here in this particular chapter of volume 2, they get into that as well. So basically, I'm going to leave you with a lab that's going to explain everything to you step by step as far as putting the privilege mode passwords, service password hyphen encryption, a command that doesn't work in the packet tracer, but it's in your book, your Cisco Press book anyway. So I write it there for you so you can know that that may come out on the test. So make sure you do know that. And we do the telnet and the SSH, and we talk about a little bit about the firewall and where would you put it and place it. So pay attention to the lab. It's a packet tracer lab. All right. And keep in mind things that we've gone over already, which is security. Like I said, the previous lecture to this one you just came from was access list. Now we're just, I guess, drilling down. They wanted you to drill down and putting username and passwords on there. All right. So pay attention to the lab, repeat it, create it from scratch so you can learn. Okay. It's not a big lab. Create it from scratch so you know what's going on and test things as you go. All right. I'll see you inside the lab. All right. Welcome, everybody. We just came from access lists. All right. We talked about securing, our network and protocols, standard, extended access list, and that weird access list that now that's been around for years, but we're just getting to know it now, which is using source ports. So hope you paid attention to that. Well, here is just in this particular type of chapter, which is securing network devices. It's pretty basic what they're asking you to do, and if you look at my volume 1 for configuring the routers or the switches, it's part of the basic housekeeping. But hey, this is volume 2, and this is a chapter that I want you to know there's specific things in here that they need you to understand. So basically, let's go ahead and do it. So right now we do have connectivity to the actual router, ping 192.168.1. Ooh, that's a weird IP address, 168.1. Let's go, fingers. All right, so we do have connectivity to the router. We don't have an IP address or anything on the switch, but we will. All right, but let's go ahead and click on the router. All right, and what we're going to do is we're going to configure the security or authentication and stuff like that they want you to do. All right, one of the first things they talk about is the secret passwords, right? They need you to type both. Enable, password, Cisco, at least know both, okay? And this is something that's been going around for 200 years. We should know by now, unless you're brand new to Cisco. Enable, secret, student. You can't use the same password from the plain text password, which is this one, to the encrypted password using MD5, using this, okay? Now, if you do both, first of all, there's no such thing. If this would have been a greater than symbol, greater than symbol, it would not, that is not enable mode. I don't know if I have it here somewhere. No, that's not, this is something you don't do in the exam. You have to go copy, run, start. But if I exit and I type disable, that is not user mode. Okay? That is not enable mode. There's no such thing as enable mode. Okay? This is user mode. That you type enable, and now those passwords will be configured take effect, because what does the command enable do? It takes us into privilege mode. So the passwords that we just configured, these two right here, are considered privilege mode passwords, not enable mode passwords. So whoever tells you any different, ignore it, just to be saying it nicely. All right. Now, which one do I type? Well, this is plain text and this is encrypted. So the encrypted will always override the plain text. But let's see if that's true. Now, you're not going to see anything being typed, but it's typing. So I'm going to type in Cisco. C-I-S-C-O. Enter. Didn't work. Let's type student. S-T-U-D-E-N-T. Enter. Well, that worked. So what I said holds true. So once we configure the privilege mode passwords, if you do both, okay, if you do both, the encrypted password will overwrite the plain text passwords. Now, as a student or as just a person that's curious, you say, well, Elias, why would you have to type both? Well, testing purposes, that's the first answer. Second answer is that they used to give in the books, which they don't give now, is if you have to revert to an older iOS, don't ask me the version, okay? An older iOS. Think about the times when I started doing this, all right? That does not understand the secret password, okay? Then at least you have a plain text password that would be configured on your router, and you still need to type in the password, even though it's plain text, but at least you have one. So there's two reasons right there that could be multiple choice questions that they're gonna ask you. All right, so again, those are configuring this very basic passwords that the router or the iOS or the router or switch, it's the same thing for the switch, will ask you. Now, we have a command that will encrypt all plain text passwords. So if I were to do, I'm sorry, do a show start, even though I should have done it from privilege mode. So you can see it's just show start from privilege mode. Any other place, you have to do a do out of it, but in your test, you can't do that. So you can see that it's MD5, and you look at that. That's awesome, right? That's awesome. All these are crackable passwords anyway. Okay, obviously plain text, but you see this is plain text. You can see it. So what we're going to do, we're going to type a particular command called service password hyphen encryption. Yes, and I tabbed the hell out of that. Okay, so what this password, let me make this a little bigger. What this password does, what this command does, it will encrypt this password. It's not going to be as strong as this. It's just going to be uppercase and numbers. So let's copy this. And again, you cannot do the do in the exam. You have to go back to privilege mode and do copy run start. And let's do a show, do show start again. Look what happens if I type show start. Let me just do that. You get an error. But if you do show start, I'm good. All right, but you can't do that. You see how I encrypted it? But look at what it's using. All right, that's the type of encryption that's using MD7. It's not going to be as strong as MD5, which is kind of contradictory to MD7, but it's using that type of encryption where it's very, very, very basic. But it's something. It's something. So that means that command that we just typed in there, and there it is right here, all right, that's going to go ahead and enable all past, present, and future passwords. So we don't have to, we at least everything will be, at least have this basic type of encryption. Okay. All right. Another thing that you need to do is, you need to go into your lines and put passwords, but let me show you the differences. Line con 0, right? Password, Cisco, login, right? This is the basic thing they show everybody. We're not going to get into the other housekeeping commands, which is exec-timeout and login synchronous and all that good stuff. I am just doing the very basic of it, right? Putting your password on there. And when you type in login, it prompts you for the password if you're coming in through the console, okay? So I'm going to go ahead and then do the VTY lines. Line, VTY will show you a ton of lines. 0, now the default are 0 through 4. Those are your 5 telnet lines. Yes, 5. 0, 1, 2, 3, 4. Those are 5 telnet lines. I always do the maximum that they have here just because, okay? It's me. All right, and then I do password Cisco. I said Cisco, I just didn't type it. Login, all right? So, and I'm going to copy that. Do WR. All right, so I turned on telnet access, okay? And I have a password on my console. So what does that mean? Exit, exit, exit. So I've exited the router. So right there is asking me for a password. That is your console password. So it's Cisco, CISCO, enter. Okay, now I type enable. Now it's asking me for your privilege mode password. Yeah, privilege mode password, which is student, STUDENT. All right, cool. Now you're in privilege mode. Now let's see if the telnet password, I can check it right through here. So what I'm going to do is I'm going to move this to one side, bring up my computer. Not that I may need to move it to one side, but okay. All right, but let's open this up. We have a firewall sitting here. We'll talk about that in a second. Don't worry about it. All right, it's there for a reason. All right, so we're going to do telnet, and then we're going to say 192.168.1.254. That's the IP address of that gig 00 interface. And okay, well, give me a password. Okay, so it's Cisco, CISCO, right? And then you have to go through the whole enable, and then student, STUDENT. All right, cool. But you see, it's not asking us for username or anything like that. It's just asking us for passwords. And that's not the way the reality works, or you want to make it a little bit more stricter than that. So let's go back into the router. All right, we're here. Let's do conf t. So what we want to do is create a username with a privilege level. Because in the book, they just tell you to do username, Bob, password, whatever. So no, because you want to give it certain privileges, right? So we want to do username, obviously me, LD is, privilege. Now with privilege, you have from 0 to 15. And you can research this on your own. So that means you can go 0, you can give it a 0 privilege, which means you probably can't do anything on there. 1, 2, 3, 4, 5, all the way to 15, which is administrative. And if you are a Googler and you go out there, because it's not going to be in any book since I've been doing this, has shown you each level of privilege that you get. But privilege 15 is what I usually type because I want administrative privileges. Okay, so you do privilege 15, password. Now with the password, you got to say 0 for unencrypted, 7 specifies a hidden password will follow, and then line the unencrypted clear text user password. So what we're going to do is I'm just going to put 0. But last, that's unencrypted. No, it's not. Why? Because we went ahead and did the service password -encryption command. So password, Cisco. And I'm making it very basic. Well, not Cisco, just to prove a point. Let's put Mango. Okay, just to prove a point. So we got username LD is privilege 15, password 0, Mango. Okay, all right, cool. All right, but I have to do something on the lines. Let me copy. All right, so I'm going to go to linecon 0 again. But this time, I'm going to say log in local. That local is saying use the username and password for the local user. Log in local. Oh, okay. So let's go to line VTY 0 space 15 and do the same thing. Log in local. All right, let's do WR, and let's take a look at our show run real quick. All right, let's do a Control Z there. Let's do a show run like you would do in your test. All right, and let's go through it. You see everything is encrypted, right? And you see the username that I just created. You saw I put 0, but look what it did, 7, and I encrypted it using the service password -encryption. Okay, so let's keep hitting enter. Scroll down. All right, there's the IP address. That's nice. Okay. And then we come here, linecon 0, password, look at it, is encrypted, okay? And that's Cisco. Remember we put Cisco in there. Remember password, Cisco? And then we said login, but now it's login local. Login local. Okay, all right. So let's exit out of the router. Let's do a Control Z there. Exit. All right, so we're gonna hit enter. Now it's no longer asking you for just the password. Now you got to put in a local username, which we did Aldias. And let's put in Cisco, the original one we had put in before, right? CISCO. No, didn't work. Aldias. Mango. MANGO. That works. Because once I put in login local, keyword local, it's saying, hey, use the local credentials that you configured on the router, username and password. It will overwrite whatever you put underneath the console or the telnet. All right, so let's see if that's true. Let's telnet into the router once again. Go to command prompt. Let's open this up. So up arrow, telnet, username, L Diaz, password, Mango, M-A-N-G-O, enter. That's it. Exit. So you're making it a little bit more, right? Because now you can create privilege levels on that particular user, and he may not be able or she may not be able to do a lot of things. Okay, so you want to set up privilege levels, not just type in a username and then a password. You want to go ahead and set up privilege levels on there. Okay, and if you want to go beyond the scope of the book, and you should, and Google it and find out what each privilege level does, go for it. Okay, and set it up. But usually, like when I worked in telecom, you had administrative rights to the router. You can do whatever you want. Obviously, you sign the policies and stuff. Don't be messing around. All right, so we're doing that. But telnet is plain text, is it not? Plain text. We don't really want to be telnetting into anything. We want to be setting up SSH. We want to do an SSH session. All right, but it's not enough to go into the VTY lines and just say, hey, transport input SSH. That's not enough. In order to do SSH, you need to do some other things first. Number one, you want to have, a domain name, because the whole purpose of SSH is to be able to encrypt the information as it goes along. Well, how does it do that? Well, you can create RSA keys with a particular encryption, a level of bit encryption. The default, I believe, is 512, and then it can go 1024, and it keeps doubling as it goes up. All right, so the higher the better. Okay, just remember your processor cycles. All right, but we go config T. One of the things we want to do, and this you really don't have to type, but I guess you're taking a test, if they ask you, because this is on by default, IP domain, and you should know this from my previous lectures, IP domain lookup. All right, that's already on, but it's not going to hurt anything. That turns on the DNS service, okay? But it's on already. People usually turn this off, okay? Unless you want to use it. IP domain -name, okay? And let's call it last.com, right? So why do I have to do that first before I actually, because if I were to go into the VTY lines and try to enable SSH, it's going to give you an error. So the things that you need to make sure you have before we go any further, you have to have a host name. You need to make sure that the DNS service is on, and you have to create a domain name because you cannot generate any keys unless you have a host name and a domain name, because the keys are generated using r1.last.com. All right, and you'll see it in a second. But there's still some other stuff that I would like you to do. IP SSH, right? And you have authentication. How many times are you going to allow this person? It's just like Windows. How many times are you going to allow somebody to log into a domain or to their computer? So I put 3. And let's take a look at the range. Let's use the question mark. You have 0. No, that's it. You're done. To 5 times. I'm going to say 3. I think that's fair. All right. And then you're going to do IP timeout, IP SSH timeout. Try that out. It can go up to 120 seconds. So we'll do the max, 120 seconds. All right. So now we're going to generate the keys. And I'll take it slow. It's very easy. It's crypto. Key generate RSA. Just hit enter. And see, it says the name for the keys will be r1.last.com. Choose the size of the key modulus in the range of 360 to 2048 for your general purpose keys. Choosing a key modulus greater than 512 may take a few minutes. So the higher key, obviously the higher bit key you put, the higher bits you put, it's going to take more processing power, more what have you. But at least, do 1024, because 512 is just, ridiculous. At minimum, 1024. In turn, it says generating 1024-bit RSA keys will be non-exportable. Okay. All right. And you see that when I hit enter again, these logging messages. Somebody once told me, hey, Last, why can't we just turn on logging? No, do not turn off these logging messages. You want these to pop up. All right. It's important for these things to pop up so you know what's going on. So SSH 5 enabled, SSH version 1.99 has been enabled. Okay. Awesome. So now that we've done that portion of SSH, now we can go to the line VTYs, all of them, 0 space 15, and do transport input. Now, this is where people get all crazy with me. This is a lab. So I usually put all, okay? So I can do telnet and SSH. If you're in a real world environment, you put SSH, and that's it, okay? But I don't want to do that. I want to do all. Why? So I can test both. We're in a testing environment, okay? So I'm gonna put all, but if just choose either or, if you know, to make it secure. All right, so I'm gonna choose all. Do WR. So let's review what we've done. We've created privileged mode passwords. We did the service password hyphen encryption to encrypt all past, present, and future passwords. We put passwords on the console and on the VTY lines. First, we just would log in to prompt us for a password. Then we created a username with privilege levels, all right, and the password was Mango, right? And then we said login local to use the local username and password. And now we just enabled SSH. But what we had to do, make sure we have a host name, domain name, right? And the domain name service is on, all right? Domain name server is on, created a domain name called last.com, did my IPSSH authentication retries and IPSSH timeout. And then I did my crypto keys. It generated those crypto keys at 1024 using the r1.last.com. And then we went ahead to the VTY lines and said, hey, we want to allow SSH and telnet in this case, but normally in real world, you want to use just SSH. All right. So let's take that out. All right. And let's try this SSH and see if that does actually work. We'll try both again. Okay. So, but let's try the SSH first. So we're going to do SSH minus L. Why minus L? Because we got to put in a username, LD is, and then who we're trying to SSH into, 192.168.1.254. Okay, and you hit enter. Now it's asking you for a password. Okay, well, I already put the username. So I'm going to put Mango, M-A-N-G-O, enter, and I'm in. So now we're doing SSH, it's encrypted, and we're able, and we're doing SSH. We're doing SSH, we're putting a local username and password, and we have that encryption going on. So that's awesome. So it's a lot more secure, right, and not doing anything on the router, okay? But remember, before this, it was ACL. So you have, now you have your ACLs that are working. Now you have all these passwords that you're doing. Now you can always implement radius in here as well, all right, if you want then for the radius, so you instead of using login local, you create a AAA policy that states, hey, it's a hierarchy, and you wanted to use the radius server, okay, to do that. And then you create that radius server database with username and passwords and so forth. All right, but this is at least the minimum they can do. Now, in your books, those of you that have Cisco Press, it wants you to type, because, we were told that, you need is a packet tracer to do this and you'll be fine. No. Now, remember, in this brand new test, there is no configurations, 0 configurations, according to the experts out there. It's 102 questions. You have 1 minute and 17 seconds per question. Cisco wants you to type enable, okay, algorithm, okay, hyphen type, script, secret, and they put they just put a password. I'm just going to I'll put their password, my pass 1, okay? That's what they want you to type. Enable algorithm hyphen type script secret my pass. There's algorithm type MD5, algorithm type SHA, and then the script, right? And then you put the password. Or secret, or what have you. One will be using an MD5, one is using a SHA, will be 8. It's either 5, 8, or 9, which is MD5 for 5, SHA 256 for both 8 and 9. But this is what's going to happen. Because if you use the packet tracer, that's not going to be there. if you type enable and you hit the question mark, that's all you got. So it's not you, okay? You need to be using an actual router with a real iOS, not a programmed iOS, okay, to do certain things, okay? So just keep this in mind, okay? This command right here, algorithm type script, and really, you know, or this right here. So you go enable algorithm hyphen type script secret, and you know, it could be, or you can put, if you just do that, it will be just MD5, or you can type in, you know, well, you would really need to type, if you type script, it will be MD5. If you do, no, if you type script, I'm sorry. If you type script, it will be 9, that will be a SHA-256. If you type SHA-256, that will be 8, which is still using SHA-256, which is kind of redundant there. But, and if you type MD5, it will use MD5. All right, so just know this right here. And if you're in the test, you're allowed to question mark. So if you do algorithm type and then a question mark, you should be able to see it. But you're not going to do it. You're not going to do it. So in your book, in table 5-2 of chapter 2 of volume 2, all right, that's page 93, table 5-2, they want you to do this. But the thing is that this does not exist in the packet tracer. So you have to use GNS3, you know, viral, and actual iOS, okay? So what we've done is what you probably saw back in volume 1 when I did the housekeeping of both the router and the switch, because the same thing we just did on the router, we can do on the switch. Same thing. We're not going to do it again. It's the same thing on either device. Now, where does this firewall come in? Well, obviously, we want firewall because firewalls have many features, right? You can create policies on firewalls, filtering. So you have access lists. Now you have all these usernames and passwords on your telnet lines or using SSH, but you want to implement a firewall as well to do traditional firewall stuff. But that's just has something called the next generation, okay, firewalls, right? Their abbreviation is NGFW. So you want to go ahead and do that. So you want to use it as a regular firewall. And again, the placement of the firewall is completely up to you. You can put a firewall here, and then let me see if I can get a little cloud somewhere. Here it is. Get a little cloud. You know, you have a little thing there. I'm not going to connect. I'm just going to draw a line to it. Let's do a fill color. Let's select red. Okay, and then you can connect them there. It didn't fill it. All right, whatever. We're gonna put it there. Oh, it was the outline that I had to put in. Okay, whatever. So you can put your firewall there, and that's normally what people do. This is facing the external, right? This would be the public side. This would be the public side. All right, you go ahead and put your firewall here that's facing out to the internet, and then he'll go ahead and have all these ports that are closed, not allow private IP addresses in, look for weird, you know, because IPSs, intrusion prevention system, or intrusion detection systems or services, what they do is one detects, hey, this is an anomaly. This is not the normal type of traffic that's coming through here. Some alarms pop up. And then the prevention service, if you have it updated, because it's based on signatures, it will say, hey, wait a minute, no, you're not allowed. Boom, and take some sort of action. And just says, hey, I detected something wrong. No, the prevention IPS will actually do something. All right, so you can put it there. But if you really want to be even more insane, you can go ahead and put it somewhere here. So you have one here and then have one here. And if you have it in this type of scenario, where this is the public and this is the private, that you have your router plugged in to your firewall and then to your internal switch. It's like a back-to-back firewall, what they consider. But these are things that you want to go ahead and do, because a lot of these firewalls today, especially, they have a lot of advanced malware protection, and you want to go ahead and use that. because if you have a traditional IPS, what do they do, right? They like using what is it's called is they exploit signatures, and they're comparing packet flows, and then they tell you, hey, let's create a log event and then take action, right? So you also have what's called AVCs, application visibility and control. Okay, and so they have a lot of things in there, all right? That reputation-based filtering, event impact levels, the IDSs, all these different things. But you want the greatest and latest, definitely, URL filtering. But you do policies, you do all these types of policies in there, context, all that. All right. You want to remember security is based on layers. So definitely you do want to implement a firewall. So not only about the security measures that we talked about in the security chapter that talks about physical security, but also doing your username and passwords, putting them on your console lines and your telnet lines. Okay. Privilege levels. And then on top of that, you have firewall access lists and then firewalls also doing filtering for you, whether you just want to use one firewall in the public, or if you want to use a back-to-back firewall where this filters, you have your access list, you have your username and passwords, and then you have this. I mean, there's a million things we've talked about in security, about honeypots and honeynets and DMZs and all these different things you can do. But this is just for networking, just the chapter is more focused, just securing network devices. Definitely, you want to take this into consideration. And this is something that you don't take lightly. Anything you're doing security, whether it's a security plus information or it's, CCNA security or a little bit beyond that, where you actually, implementing all these different things, it all goes together. These are all things you need to implement in your network to make it secure. Again, I'll leave you with this thought. There's no secure network. It's just how bad the attacker wants to get in. So it's up to you, the engineer, to take the proper steps, do your due diligence to mitigate the risk that you have, right? You want to, if someone's attacking you, you already have things in place, right? And obviously disaster recovery. But we'll leave it there. And then if you want to go over and over again, knock yourselves out. I'll see everybody in the next one.